Dear students, in this session we will discuss scan conversion. Now, the process of representing continuous graphics objects as a collection of discrete pixels is called scan conversion. It is responsibility of graphic systems or the application program to convert each primitive from its geometric definition into a set of pixels that make up the primitive in image space. Now you were thinking that what is this primitives? As you know, some basic figures like line, triangle, circle, parallelogram, these are termed as primitives in the graphics. So, in case of line, it can be possible that any pixel may have any floating value like 2.7 as a x coordinate, 5 as y coordinate, which will not be considered by the system. Therefore, the process of making those coordinates according to the system's assumption, that is, those will be considered as 3 and 5 to plot the pixel in scan conversion. So, we do a scan conversion of point, line and other primitives. So, a scan conversion of a point. A mathematical point x y where x and y are real numbers within an image R needs to be scan converted. This may be done by making x dash and y dash to be integer part of x and y. X dash is equal to floor x and y dash is equal to floor y. The origin is at lower left corner of the pixel grid. All points which satisfy x dash less than equal to x and less than equal to x dash plus 1. Likewise, y dash less than equal to y and y dash less than equal to y dash plus 1 are mapped to pixel x and y. If, for example, we may take 1.7 and 0.8, which will be represented as 1 and 0. If consider for another point, that is P2, 2.2 and 1.3, that will be considered as 2 and 1. So, you may assess that being away from the previous P1, but both are considered as same way by rounding their fractional part. So, by considering such way, the points are scan converted. The next, that is line. Simplest strategy for a scan conversion of lines is to compute the slope m as delta y by delta x, to increment x by 1 starting with the leftmost point to calculate yi is equal to mxi plus b for each xi, and to intensify the pixel at xi comma rounded yi, where round yii is equal to floor 0.5 plus yn. This computation selects the closest pixel, that is the pixel whose distance to the true line is smallest. So, considering this way, we identify the points for a line. We can eliminate the multiplication by noting that yi plus 1 is equal to mxi plus 1 plus b is equal to mxi plus delta x plus b is equal to yi plus m delta x, and if delta x is equal to 1, then yi plus 1 is equal to yi plus m. So, we write various algorithms to line conversion. The DDA, digital difference analyzer algorithm, is a mechanical device that solves differential equations by numerical methods. It traces successive x, y values by simultaneously incrementing x and y by a small step proportional to the first derivatives of x and y. In this case, the x increment is 1 and the y increment is dy by dx, which is termed as m. This is the algorithm. Immediately using the algorithm, we will draw the line. So, on screen you are seeing that there is a function named line, void line with arguments like int x0, int y0, int xr, xl and int yl and int value. So, with the execution of this algorithm, we do line scan conversion. The next one that is circle. The sRGP does not offer a circle primitive. The implementation is done by treating the circular ellipse R as a special case because of its 8-fold. sRGP, that is systematic raster graphics package. The equation of a circle centered at the origin is x square plus y square is equal to r square. So, for y, we say y is equal to fx as y is equal to plus minus under root r square minus x square. To draw a quarter circle, the other quarters are drawn by symmetry. We can increment x from 0 to r in unit steps, solving for plus y at each step. So, with the use of 8-way symmetry, we complete a circle. Consider first a circle centered at the origin. If the point xy is on the circle, then we can easily compute 7 other points on the circle as in the above figure. Therefore, it is required to compute only one quadrant, I mean 45-degree segment, to determine the circle completely. For a circle centered at origin, the 8 symmetrical points can be displayed with procedure circle point. The procedure is easily generalized in the case of circles with arbitrary origins. So, these will be discussed and shown to you all on the computer by using program. So, this is the 8-way symmetrical circle point function. Consider a circle centered at the origin with point xy is one of the circle. 7 other segments can be drawn, points on the circle as in the figure. So, here you will on screen seeing 2 figures. In a smaller figure, you will seeing the points which are scattered near the curve circumference line of the circle, and that is shown in for 45-degree only. So, by this way we do the complete circle. So, next one is for ellipse. A standard ellipse centered at origin, I mean 0, 0, 0, described by the equation f x y is equal to b square x square plus a square y square minus a square b square, which becomes 0, where 2a is the length of the major axis along the x axis and 2b is the length of minor axis along the y axis. The midpoint technique can also be applied to more general conics. First, divide the quadrant into two, as you are seeing in the figure. Regions in the point at which the curve has slope of -1. That is clearly evident in the larger figure of the screen. The vector that is perpendicular to the tangent to the curve at point P is called the gradient, and this gradient factor is showing you on screen in the smaller figure. Gradient are defined as f x y is equal to delta f by delta x I plus delta f by delta y j, which by equating them equal to 2b square minus x I plus 2a square minus y I. So, the boundary between two regions is the point at which the slope of curve is -1. Thus, if at the next midpoint a square within bracket yp minus half less than equal to b square xp plus 1, so we switch from region 1 to region 2, and by this equations, by solving these equations, we complete the calculation. Now, all these I am going to show that how a line, a circle and ellipse are works on computer programs. So, next move to the IDE for practical session. So, students, it is the program based upon the algorithm which we have just seen on the slides. So, with the use of this program, we will see how a line is drawn on the in the graphics. So, let us execute the program, control F9, and now it is asking that how many points. So, for a line we use to enter 2 points, and now it is asking the starting point and end point coordinates. Let us give it 200, 100, 500, and if we have to draw a straight line, then we will put here end point y coordinate same as it was of the starting. So, I have put here the 200 same. So, you will see that a line which is appearing on the screen, that is a straight line. So, this is the way by which we used to draw lines in our graphics. Now, we will move for another primitive like circle and ellipse. So, to draw a circle, we execute another program. So, this is another program to draw a circle, and the algorithm which we had just discussed about the put pixel. So, we are using this, we will draw a circle. Let us execute the program. Here it is asking for the radius. So, we are giving it 50 centimeter. Now x coordinate 200 and y coordinate 200. So these are the coordinates, I mean the points where the screen will be drawn. So you will seeing on the screen a circle has been drawn in this pink color. So by using the algorithm, we develop computer programs and put the inputs like the radius of the circle along with the position of that circle and draw the circles. Now we will draw the ellipse. To draw ellipse, we use the program, and with this program we will see how a ellipse is drawn in the graphics. So this is the complete program using the algorithm which just we have discussed in the slides. So it is asking for x and y coordinates of the ellipse position. So let's put here some value like x coordinate is equal to 300, y coordinate 200, and the length of x axis length and y axis length. X axis length we will put 300 and y axis length are lesser than the x axis, so we will put here 150. And you observe on the screen how the ellipse is being drawn. So now you will see the ellipse has been drawn with the program. So using the algorithms which we have discussed today, based upon those algorithms the programs are developed, and on the using these programs the various primitives like line, circle or ellipse are drawn in the computer graphics. So that's all on the scan conversion. Okay.